Started. Okay. All right. Let's get started here with presentation 2 of heat transfer and boiler systems. I'm going to dive in a little bit deeper. Going to talk a little bit about some Spirex crossover stuff. But what I'd really like to start with is something I left from last week. I'm not sure I gave a very good explanation or explained this properly, and I wanted to maybe just go over it really quick just to make sure everyone's clear on it. And that is open and closed loop cooling systems. So the heat transfer system, we kind of covered that, heat transfer, pump, and valves, and all the ancillary components of that, but specifically the cooling loop. So that would be, if you're trying to temper the temperature, you're going to maybe it's an application where there's a cool down process to the jacket. And the difference between open and closed loop cooling, I don't believe I explained too well last week, so we're going to give it another shot here. Last week I'd focused on the solenoid valve, and that was pretty inaccurate. And what I want to explain is solenoid valve is essentially part of both of them, or some kind of valve, we'll say. That opens, the cooling starts. But the open loop cooling is specifically, and you can see by the drawing, kind of illustrates it the best. You're actually adding, in most cases, water to an application. I mean, you could theoretically do it with heat transfer fluid, but then there's a whole, containment thing. And what you're doing is you're actually adding direct to the heating loop itself. So in the case of water, that's easy, right? You're adding cooler water to the already hot water to temper it. And at the same time, you're draining the excess, right? You're not going to overload the system. So you're going to have to drain at the same time. So the valve will be kind of, it's, your heat transfer system, which is essentially a closed loop anyway, you're adding to that and draining at the same time. So that is an open loop cooling where you're actually adding to the heat transfer fluid a cooler and tempering the fluid itself. Whereas in a closed loop cooling, and maybe that's where I got tripped up last week, the heat exchanger exists, and you're still opening a solenoid valve to add the coolant, the water, whatever it is you're using to temper the process fluid for the indirect heating, but you're not injecting it directly into the process. It's indirect heating. It's through a heat exchanger. Obviously, the water or the coolant itself goes in and out, and that's ultimately controlled by the same controller. That's true. But that is essentially the difference, and if there are more questions about that, please let me know. But I don't think I explained that properly last week. So when I was showing this diagram in the top left for the CMX and the CMXO, that was inaccurate. It was not. The CMXO has an exchanger. It is not an open loop cooling system, which I don't know if I was very clear about that last week. But essentially, this drawing in the bottom would be that you can see the exchanger there. This would be the CMXO. So hopefully that clarifies that a little bit better for everyone. I'm going to assume no comment means we're okay. We're kind of clear, a little bit better explanation of that, I hope, for everyone. And, another thing that came with that question was, this is specific to CMX, CMXO. When you get into larger heat transfer systems, it was, the exchanger itself, the cooling system is oftentimes exterior, supplied by the customer. Not very often on the larger systems is it supplied by us. We have a couple bolt-ons that we can provide that gives you the exchanger area for the cooling, but it is a separate exchanger altogether. And in which case the 4080, which is also you probably saw the letter from marketing last week, where even our CMXOs are now going to incorporate the 4080, which will control the cooling loop as well. Now, it'll do both open and closed loop cooling, but for the larger systems, again, that open loop cooling is really not an option. We're using heat transfer fluid, we're using higher temperatures, and essentially, I can't even think of an application where you would not have a closed loop cooling for anything outside of water. Hopefully that is a little bit better of an explanation. I give you a chance to ask me any more questions before I begin. Fair enough. Moving on. So as I mentioned before, the selection, you're going up in temperature, you're going up in size, and pressure. That's basically how all of our stuff goes, and obviously the cost and design follow with the process. But I also want to talk a little bit about scope of supply. Our package systems, they come with the pump, the valves, the pressure gauge. Again, that heat exchanger I illustrate again just from our standard drawing is provided, unless you're buying the CMXO, exterior to our standard systems in the catalog. But there's a lot of other things to consider when sizing your unit, especially for your customers, the application, and there are also good talking points, as we went over last week. The discussion of just walking through the application with the customer, the other products that go along the line of scope of supply, and that's where you can really get your value add. We're kind of focusing on value adds, what we can bring to the table, things we can offer a customer, an application, and those do fall within the parameters of the entire scope, right? Maybe it's a type of pump, maybe some controls that also control start-stop of other process systems, the valving. We mentioned the cooling module a few times. Again, we don't make them, we purchase them. More than likely, but we do have other sources to supply those. And oftentimes it looks like this. These are, as luck be told, I help them find Spirex valves. But it could be expansion tanks. It could be, more parts to the process where we add value to the customer, ultimately, add dollars to our sales cycle. And I got, a lot of examples of that, and I won't go into too much detail, but even controls. This panel alone, went from a nice $20,000 standard panel to every little bit of value add we could throw in there. In the end, this panel was about $100,000, and they were happy to pay for it. When you think skids and you're adding angle iron and, different things that you may not consider, paint color. If they want a specific type of paint, maybe it's pull boxes. You can see these on the elbows and the corners. That was all specialty designed, and guess what? That was value add. That was more money coming to us. We were supporting the customer with what they needed. You can even see a nice, they wanted a temperature indication. That can be just a gauge on the outlet. Now, it has a lot of other controls, incorporated into it, but that is a separate item that becomes an adder all along the way. So in talking of that, how do you get a quote? What are we looking for? How do we design these things? How do we size them? And that's what I'm going to focus on here for a little bit. Check one thing real quick here. Okay. Even in our catalog, we say, there's a process, a jacketed vessel, you're heating an exchanger, you're doing something with our heat exchange system. Something that often gets missed and we have to be really, really careful of, and I do want to point out, is when you get a data sheet, hopefully you get a data sheet, not always, and we have some that we can supply, and I'll provide them with this presentation as well. But when a process has a data sheet, you have to be sure that they're considering the losses, our side of the equation. A lot of times they calculate it for their process conditions, for their application, and that's all fine and good. And a lot of times the safety factor takes care of it, right? 20% is the standard. Maybe drop it down to 10 for larger heat transfer system or for larger applications. But you have to be careful. Maybe we're getting the heat transfer system out of the, hazardous area, or maybe it's a pharmaceutical application, and the system itself could reside 50, 100, even, 1,000 feet away, And we have to consider, are they insulating their piping? But it also gives you an opportunity to offer alternate options like, well, did you think of heat tracing the lines and, some of the other things we offer. So you definitely want to consider that point of the equation of the losses. You may have a set data sheet, and that's all fine and good, but you want to make sure that you at least have that conversation with your customer because, again, you're building your credibility, you're walking them through their application, you're possibly pointing out something that, who knows, maybe they missed. So how do we get pricing? How do we get a quote? Now, our e-quote system can be confusing. I get it, but there's a reason for done the way it is. We have all these design sheets in our catalog. You walk through our catalog, it's very thick. We also have very many product segments. And how they incorporate together, that's essentially where we start to create multiple data sheets, multiple requests. And it's just important to acknowledge it and know what you're following through. But if you need, as defined by Chromalox, a heater and a panel is a skid system. Well, that could be under circulation, heater and a skid. It can also be under control panel option. Data sheet even has heater and panel. Package systems, heater and panel. You know, use the package systems when you can. Keeps it straightforward and also gives you the opportunity to add to the application when you and the process to your customer. But when filling it out, application details is a must. Like the more details you can provide, the better you're getting off on the right foot is the point. It's going to ask you for heated medium every time. That's just, you know, gas or liquid, right? Temperatures are important because it's going to kind of start the design down the right process. AE is going to know right away in a high temperature application, oh, I need a special pump. This isn't your run-of-the-mill thing. Or on the inverse of that, they're going to know, and this happens to me, I would say once a week. I get a call, actually it happened last week, and I'll give that example in a minute, where, you know, you think you have this real in-depth, difficult process to do because you got this long data sheet, you got this book of specs, and in reality, if you're able to identify a couple key points, maybe it's just a standard MOS out of the catalog. Done. Lead time, everything provided right there. And guess what? Now you're first in the door. So it's something very important to follow. And then the other things are standard, right? Voltage, wattage, phase, that's easy. Mounting position, inlet size, you know, that's going to matter when they start to piece it together and put it together. But you should know this up front. But more importantly, the application details are the way to go. But these are going to be your required fields if you're using the eQuote system. I wanted to show you that because you're going to need to know at least to ask those when you go to fill out the data sheet in the system. Now they don't give you a data sheet. You don't know what those numbers are. You don't know what your process is doing. Back to the discussion with the customer. These are live documents. You fill them out. The blue spots are, you know, really like just filling out a sheet anywhere, really. Provide these to your customer. They'll be provided with a presentation at the end. A lot of times it helps the customer identify what they need. And, you know, this is the same one on the left that you would use for a heat transfer system. It's going to ask you flow rates, connection sizes. Even though it says circulation heater, you can use it for your systems quote. ASME data sheet, something I'm bringing up for this, but also anything else that you're dealing with when you're dealing with flanged heaters, circulation heaters. Remember the PE306. It's required for an order if you need ASME. So don't, you know, if you provide a purchase order, you enter it in the eQuote, or in the, say you get an eQuote and you enter that as an order and you think, oh, that's fine and good. It's got to be approved, pricing checked, goes all the way to design engineering until they come back and ask you for PE306. This can cost you a week or two on design alone. So that's on us. That's on field sales. We got to ensure that we fill out the PE306. If ASME is required, we got to provide it. I just want to point that out because that gets forgotten a lot of times, and it's bit me in the past, believe it or not. And then, you know, maybe you're not comfortable with filling all that out, or they don't know the inlet outlet sizes. You can always get it started on the eQuote system. We got the basic data sheet, the simple engineer data sheet. Again, almost too many options to get a quote in the system, but just make sure you're providing the application details. Enough about that. Pumps, motor, bleed valves. We talked about pumps last week, but bleed valves. That's an added item that we can provide. That's how you get the air out of a system at the high points. Certainly something that's value add. Expansion tank. We have standard options in our catalog, but that's an adder. A bypass line. Now, our standard larger design systems don't always have this. Our MOS does not. But it's something you want to bring up because maybe the customer hasn't considered that. Why would you have a bypass line? Well, two reasons. One, you want to keep the system up to temperature while maybe the process is being taken offline. That's fine. Or you're doing something else with the process altogether. Keep the system up and running at temperature. Or more important than that, they'll have a bypass line if there's maybe an overpressure or a problem with the system. So that's something we can easily provide. That's an easy design option. And then troubleshooting. There is a standard sheet. We've had it for years, but the question of troubleshooting comes up all the time. And this is, you know, it seems simple after you read through it, but it's a real quick offering to the customer of, okay, I'm having some really problems. Okay, quick. Let's walk through this. What's the problem? You know, you got leaking valves, you've got, broken belts, whatever it is, I'll provide you the sheet and you can provide it to them. But the reason I show you this is I also want to point out that's your inlet for, hey, let's talk service. We can have a tech out there. We can, these are general problems that you have to take care of yourself, but wouldn't it be better if Chromalox offered you that option, that service provided? Any more about that? Any questions so far? Good. I've brought this up many times. This was a little left over from my last presentation, but it has a great illustration and it's a great segue to talk about boilers for a few minutes. This is a boiler system. Obviously, everyone's heard me talk about it many times. We designed it a few years ago. This was actually for steam tracing, ultimately. But think of a boiler system. It's not much different from a heat transfer system. You got your gauges, your pressure temperatures, your valves, your heating elements, and a chamber. It's kind of about it, as long as it's sized properly. So with the introduction of medium voltage to our product line and our offerings, we've got medium voltage boilers now too. So, much larger design capabilities. But a couple key things I want to point out to everyone on the call so you can take with you. A lot of times you get somebody on the phone or you get a quick request. If you're talking steam, they're talking pounds per hour of steam. That's most commonly what you're going to get as referenced. Hey, I need 100 pounds of hour per steam or 50, whatever it is. Now, it's not exact, but for the easiest rule of thumb, it's 3 pounds of steam per hour for 1 kW. That's what it supplies. Now, it obviously varies with pressure and temperature, but that is a close estimate, and you should use that for everything. If you need a quick answer or just to get an idea of the magnitude that you're looking at, are we looking at a standard product, which falls right into the range you see on the left, or are we talking something a little more extensive, like our medium voltage line, which was introduced by Mark Wheeler last December. And I'm pretty excited about this because, as I pointed out before, this is not it's not something that we're competing in a known environment, meaning, there's a lot of other medium voltage boilers out there. No, we're actually competing against different technology for the most part. Gas-fired boilers are going to be their biggest competition here, which there is no equivalent to our electric boiler. Unless you're talking maybe electro boilers, which are a little bit different, but they're not going to meet the pressure ratings and design constraints of these. These are more going to be on the industrial side, larger systems. And as you can see, a couple key points of this new boiler system that I want everyone to take away from this. One, the voltage rating up to 6,900 volts. That's pretty nice. Standard sizing, when the catalog pages come out, up to 7.3 megawatts. That'll be standard sizing. But how boilers work, and we talked about this last week, you're just supplying steam. So if you put one next to the other and they're running in parallel, that's fine. It's literally an accumulative output of steam. So if you need designs higher than 7.3, you just add another boiler to that. So sizing, pricing, design, I have a feeling this is really going to take off for us in the next year, and I'm pretty excited about it. Now, we have had a specialty request and have been able to design up to 17 megawatts in one vessel. And I haven't got confirmation on what diameter vessel that is. I suspect it's probably 48-inch diameter. It's probably not horribly large, because that's another point to these medium voltage boilers I want everyone to take away from this. When you're talking to customers, when you're reviewing and basically, explaining to them that we have this technology available, we have the sizing, these boilers are going to be a third, a fourth, I'm being conservative here, the size of the gas-fired equivalent. That's huge. That's less real estate. That's easier to monitor. There's a lot of advantages here beyond what we put on paper that we need to illustrate to our customer. And I think that is a big key component right there of just the physical size. These are significantly smaller. The location of them doesn't follow the standard boiler area classifications as traditional gas-fired boilers do, where you have to have exhaust, the boiler operator, incoming gas lines, yada, yada, yada. This doesn't work that way. This is no different than our circulation heaters. This can be mounted in, areas, on different floors of buildings, outside, it doesn't require as much constraining permitting as a gas-fired system would. And I point that out because actually Scott Stevens said something last week that was I didn't even think of until he brought it up to me. You can check boiler installations just on government websites in your area. I mean, right there you've got a target customer list just from that alone. You'll find out if they're getting expansions. I know Industrial Info labels them a lot, and it's a good place to look for this. So I think this just adds a whole new element of opportunity to Chromalox as we move forward. Enough about push and direct connect. Let's just talk boilers in general. When you go for a request, even for a direct connect boiler, you still use the boiler eQuote template. No different. Now it's going to ask you water type. So is it city water? Is it treated water? That's going to lead to maybe what kind of materials we're going to use. So be conscious of that. Obviously, design pressure, your standard's 150, but we can go higher than that. And we can go a lot higher than that using non-traditional designs, using, like you saw, the horizontal boiler. It looks like a circuit heater. We can pretty much design whatever we want. I think it was pressures up to 1,100 PSI on the list. And then you're going to obviously need approvals, but it's standard electrical approvals, right? CSA, UL.
Hey, Derek.
And then there's also, yeah, hey, what's up?
The materials that we have available on the medium voltage, what kind of materials do we have available for that element?
My understanding is Incoloy and stainless.
Just Incoloy and stainless?
Yeah, just Incoloy and stainless. What were you hoping for?
I don't know. Just curious.
I don't think they can make a medium voltage like copper element, but I'm not sure you would anyway. Most of the boilers I've seen, they've gone away from the copper element anyway.
Yeah.
But those are the two that I know of. I think obviously they can make specialty materials if they need to, but those are the two main kinds. And I don't even know if that's 304 or 316. I'll have to find out. I'll tell you what, I'll be sure to, in my summary email, I'll make sure I get an answer on that. That's a great question, though.
You know me. I'm never inside the box.
No, I love it. No, it's a great question. Great question. Now, the vessel can be anything we can make, right? Although if any of you have been here for a while and had to get an Inconel vessel before, oof, that's expensive and that's a lot of work. But it can be done. But as far as the elements go, I'm not entirely sure. So I will make sure I get the confirmation from Mark here in a second. Okay, perfect. Great question. Again, same thing as before. I know these drawings and even these data sheets we have are pretty much outdated, everyone on the call, but the technology hasn't changed. The boilers, the same thing with the startup on boilers. One thing I want to point out and make sure everyone understands: our boilers are controlled by pressure. You set a pressure on them, they'll trip on, they'll start heating. The vessel itself builds up pressure until it meets that point, and either you call for steam at that point and open up the valve and let the steam out and it continues to make pressure, or you don't and the elements turn off and it stops creating steam. Along the way of process, we talked a little bit about condensate return. This is a very simple loop. A much more detailed loop to discuss, we'll discuss next after this slide. You got troubleshooting, right? There's only a few things that can go wrong. Your elements went bad, you've got a overpressure, or you're leaking. Maybe a control is malfunctioning. And beyond that, that's when you're selling service. That's when you're getting Ron Temko on the phone, you're contacting Bruce Barnes' department, and you're getting somebody out to work on it. But as far as the Segway goes, and I was one off, this is not unlike our owners, Spirax Sarco. So something that, they control the steam loop, and I've brought this up before many, many times, but steam quality is a real issue for a facility, for a customer, for whatever process they're doing. Now, we can provide the steam, no problem. We were talking about boilers. We've got boilers up to anything that compete with gas at this point. It's great. Their focus is the actual quality of steam delivered, and I'm going to talk about this for a little bit, just so everyone has a basic understanding of steam quality. So I mentioned earlier with the heat transfer system, not always considering the losses to and from the vessel. You can calculate for the process or the heat generated by the, needed for the kettle or the process or whatever it is, but you don't think of how the heat's, how to get the heat there and the heat loss coming back, which you have to make up for as well. Now, on a boiler loop, oftentimes they're gas fired. The boiler's, on the other side of the building or whatever, and all that, those steam lines, all that quality of the steam, it starts to condense. So we talked about steam traps. Now, steam traps, it's just the industry term. The steam trap itself is not catching steam, it's catching condensate. Condensate is where the steam obviously turns back into liquid. It's given off its BTUs, it's given off its thermal output on its way there, and what is that? That's your line losses. And they'll put steam traps along the way to improve the quality of steam. We're getting the moisture out of the steam, and we're letting the steam go, but we're getting the what's already condensed out of the way. And that improves the steam, the thermal input to whatever process we're providing. Another way to do that is with steam separators. And they're not really all that technologically advanced. I mean, there's a lot of calculation that goes into them. There's a lot of precision in the craftsmanship of both items. But it's basically just a series of weirs, as you can see in the picture here on the left, that essentially, as the steam flows through or the flow of steam is going, it knocks the condensate out of it. And you can see at the bottom, condensate to the steam trap. It's going to send it to the condensate return system and send it back, all in the ultimate goal of just improving steam quality to your process or your application. And they'll apply these in different places along the steam loop in a facility, and that's their expertise. That's what they're providing, right? They manufacture the pieces and parts that go to the steam loop, but where they apply it and how they apply it all goes to the equation of improving the efficiency and the quality of steam. I go down that long story just to explain, this is something we've been providing for years. It's not a mechanical device like a steam trap or a steam separator. It's a superheater. We do this all the time. Now, this is a very large one. I agree. This is not your typical steam superheater, but this is a steam superheater where you're putting the thermal input back into the process, back into the indirect heating source in this case, which is steam. And we have standard ones in our catalog. We do this all the time, and maybe everyone on the call, I just hope you can take it with you that we're doing this already, and we may or may not realize it. I won't mention his name, but one of the Spirax guys I work with, I had mentioned and started showing him this, and he's like, he didn't even know this existed. So I think it's just a great segue for some things to discuss with maybe your Spirax counterparts. It's certainly a place that we can add to their scope of supply, and we work together. But more importantly than that, it's an opportunity for you. If steam exists, we're not providing the boiler, we still have products to help with that. And straight out of our catalog, steam superheating, is the process to increase the enthalpy. I'm going to bring this up to everyone because back we're talking steam quality. Now, not in the purpose of losing anyone, I'm going to provide you with these charts, and I just want to take everyone down this road really, really quick just so you have exposure to it. Let's talk enthalpy. That's the thermal energy based on pressure and temperature. This is specific to steam and steam tables. Now, steam tables, it's the same value for steam. It's based on temperature and pressure, but it's basically the heat content that steam has to give off. And along the way, as losses happen, that's where you come into the story. You'll hear the term steam quality come up a lot, or saturated steam. And I just want to touch on this just for a bit so you can take it with you or at least have some exposure to it. I'm going to give you these charts. Ironically, I used them years ago, and they're actually from Spirax Sarco. Well, let's talk superheated steam. So we have a superheater. We can add thermal energy, enthalpy, into the steam line. We don't have to just take the condensate out and recirculate it through the boiler. We can improve the quality of the steam in the line itself with our steam superheater. But, you know, just so everyone can take a little bit away of what that means, it's interesting how the math works out. So steam itself, 100% saturated steam has a value, and that's the value here, saturated steam. You'll see it here in the table. And this is in BTUs per hour. So, you know, in atmospheric pressure, guess what? Water boils at 212. We all know that. Well, if it's steam at 212, it has a value of 1,150 BTUs per pound. So back to that earlier when I was talking about sizing of boilers, they'll talk, I need 100 pounds per hour, you know, 50 pounds per hour. That's essentially where that value comes from. And you know, if you raise the temperature, you keep the same pressure, you're superheating the steam. You're adding value to it. And you can see where some of those numbers come from. I'm going to give you the charts. They're real quick to walk through. I'm not going to spend a lot of time on this, but I at least want to touch on it. You know, a quick application, just because you might hear it, you might come across it. Somebody has, I got 150 pounds of steam. It's 80% saturated steam at 40 PSI. If they're working in boilers and they're working in steam, they're going to know this. They're actually Spyrex themselves make monitors that can tell you the quality of steam at any place in the line. So that comes into the discussion. Hey, I've got 80% steam. I want 100% steam. How do I get there? Well, it's really simple, actually. The enthalpy of the evaporated steam, that's where the 80% comes in. That's where we're talking the quality of steam. Well, you apply that factor to that. Sorry, let's get off. There we go. And so it's accumulation of the value of the water, the value of the steam, ultimately is your 100% saturated steam. But if you don't have 100% saturated steam, that's where the percentage comes in. If you take the percentage of steam, it's the same, the value for the liquid, saturated liquid stays the same, and it has to equal that number. Well, guess what? It doesn't in the value of steam. So when I got 80% steam, I got 50% steam. Whatever they tell you, that's where you apply that number, and it's the difference. So you can see just simply by the math, I won't bore everyone on the call, but I add the two numbers together. They obviously do not equal that. And what that does equal is the value I need to add into my steam, that steam line at that point to bring it back up to 100% saturation. That would be the superheater, as opposed to taking the condensate down the condensate separator or the steam trap and running it back to the thing. If we can put that enthalpy back in there, we're bringing the steam quality up. In the case of this, we're revaporizing liquid, essentially. And so you've got that value per pound. I know my X needs to go a little further over. I've mentioned in this example 150 pounds per hour. You get this BTU value. Guess what? It's 8.2 kW. And I take that with you because that's essentially revaporizing some liquid. That's that condensate, right? So in the chart, and I'm going to give it to you, as you move up, you may notice that also the line goes away. There's no value below where it's not steam. And that's based on pressure and temperature. As your pressure goes up and your temperature goes up, that's where steam is generated. So in the case of superheating steam, you want to superheat the same scenario to 500 degrees. Well, we knew it was 80% saturation. It took 8.2 to make it to 100% saturation. Now we want to superheat it. Well, that's simple. We know the value of superheated steam at 500 degrees and 40 PSI. It is 1284. Well, it's just 1284 minus the 100% saturation, which is this number. Now, that's 200 degrees difference. That's not just going from 80 to 100%, revaporizing. So remember that if any of you guys are in my technical basics, we talk about the heat of fusion, the heat to change state, right? Latent heat of fusion. Or heat of vaporization, I'm sorry, that's melting, heat of vaporization. Anyway, you to raise it 200 degrees is basically that number to that number. There's your BTUs per pound times your 150 pounds. It's only 5.9. It takes a lot less to superheat steam than it does to improve the quality of steam. Everyone follow me on that one? I would assume silence is a yes. Moving on. anyway, those charts will be provided to you. If you want to go through it, I have a nice little equation and walk through step by step. But I wanted you guys to at least, and gals, to know where those numbers come from and the charts they're at, because we're going to obviously be doing more and more steam design intensive stuff later. Now we have a lot of white papers available on steam heating, electric heating versus gas. I know they're creating some more, so pay attention to those. We'll provide those with you. But this one here is the best one to talk to with your customer. When you're trying to convert them over to talk about using an electric boiler system, I know this is used for the direct connect a lot, but it holds true to even the low voltage stuff as well. It's cleaner, emissions. You can put it right next to the process. When you're selling steam, I really think we have a lot of opportunities uncovered for our boilers in the marketplace. I just think it's a great place to grow. And then, some more talking points. We'll provide that with your design, but, look at the package. Way smaller package. It's an easy sell to a customer if they design it in or replace existing equipment. Back to how do you get pricing and designs for this. I'm going to skip over to the configurator here in a second, but it's a little hard to read, so I just want to touch on the key points for everyone to take with them. In the case of a boiler, if you're using the configurator, it's going to ask you two questions. It's going to ask you, I know the model I want. I picked it out of the catalog. I know exactly what I'm designing, so I can just get a price and do that. Or it's going to say, I don't know. I need help. And it's going to literally walk you through a series of, I think there's 7 questions. And you say, in the case of this, the water quality, the same questions we started with on the data sheet on the eQuote system, but it's just going to walk you through them, and then it's going to ultimately lead you to, a CES, CMB, the type of model number you should follow. The CMX, as I started this whole presentation with, we talked open closed loops cooling, but something I mentioned last week and actually held true because it came up twice after our presentation, that our CMX, the water glycol system, the lower temperature one, is only rated to 24 kW. But you can take the exchanger out of it, the cooling exchanger, and put a secondary heater in it, essentially doubling the kW. So we have kW offering. There's not a gap between 24 and 50, which is the low end MOS. It's a special make CMX. We have a 36 and a 48 kW. I want to make sure everyone knows that on the call, because there isn't a gap there. It's just I guess not as well known that is an option available. And then the open loop, closed loop cooling. We talked about that early on, but when you go from open loop, obviously we're injecting water into the system. No need for much. But on the closed loop cooling, we have the exchanger again. And it specifically lists the square footage of the exchanger. That's the only one you can choose from. That's the exchanger that we're swapping out for the other heater. That's basically the 2 biggest options. You've got the door interlock, so if you open it up, obviously you're cutting power, and remote start stop, or if maybe the automation of the facility likes that. Something to point out in the CMXO, again, they have the designation of heat and cool. You can purchase it without the cooling, but most commonly it comes with you want it with the cooling. But again, as I mentioned before, the 4180 is now incorporated with this unit. The 2100 is, like I think the note said, or the marketing announcement said it was 20 years old or something like that. That's true. They're all going to be uniform and use the same controller, the 4080. And then you move to the medium size oil and water systems, which are, it's just been a great addition to our product line, and we've been very successful with that. And with that, I'm going to just skip over to, boom. Like I was mentioning, like I said, it's a little hard to see in this. That's why I wanted to show you on the presentation. Of course, it logged me out. Back to the boiler. Maybe the live demo is going to take a little longer than I thought. There it goes. So, like I said, very difficult to read, right? But you put your initials in. So if I know my boiler type, I can pick it and just design it. Or if I don't know, it starts asking me questions. Do I know the use of, do I need to use stainless? No. Do I need, down here it's asking what kind of approvals already. And it basically walks you through. You just yes or no answers. You know what size you want. Yes, I want somewhere around there. Boom, it's put me in the CHS. I know I want a big one. Pretty simple. No need to focus on that too much. The point out on the CMX, as I talked about in the presentation. You have the open and closed loop we talked about. However, you just want heat only. That's the selection you're going to have to select. Now you have the option for the 36 and the 48 that I discussed. And so, as simple as that. And then, the MOS, I was going to show it here, but it's pretty simple just to go back here for the, for the aspect of time. You'll notice the selections they follow exactly with the catalog. They also follow exactly with the price guide. And I want to point that out for a minute because, a lot of times, often we forget that there's a standard price guide to all of our stuff. So if you know what KW you need, if you know what boiler you want, you can look it up on the website search module. You can use the configurator, but if you've walked through and you've gotten used to this, it's important to know, for budgeting, pricing, anything, we have published price guides for all this. And especially our catalog items, it is unbelievably easy to price out of the chart. Your selections, your options, if you need a suction gauge on the inlet side, you need special SCR trim load. All the pricing is done in the price guide. I'll provide it obviously with the presentation. It gets updated every year. It's the same pricing. It's not like a immersion heater with different immersion lengths and all that, and sometimes the list prices bounce around. These are set. They're set based on KW and design. And oftentimes, as a little tip, if you're doing some specialty design, we'll say MOS or any of these systems, design the closest thing you can before you send it into AE and say, I need something like this, but I need X, Y, color, whatever it is. It's just a way for you to help yourself get information back and relay information. A couple other things in the price guide I wanted to point out. Your immersion heaters. The LTFX, when they went through and did the marketing piece on this, they did a really fantastic job. But, somebody's talking to me, 1 second. Yeah, they quit. All right. The mounted panel. I want to point this out because the sensors are also pre-wired. What does that do? That puts the quality and the connection on the factory. I'm not trying to give them a hard time, but that's a value to the customer. Hey, you don't want to worry about your electrician to make sure they wire them up properly, or they use they wire the yellow and red thermocouple properly. It's taken care of for you at the factory and tested. And it's actually quite a bargain, in my opinion. And that is, the mounting control panel. That's the adder right there in the catalog, list adder. It at least gives you a place to start. It may not be where you end up, but it's the discussion to have. You can do this with our traditional heating elements as well, or plant shears like a TMI, a TMO. Same thing. I think it's a great option to offer customers and a value add for everyone. Also, skid mounting. When you're starting to add to scope or having that discussion with your customer, we have list pricing to start with. Have the discussion before you get the final number. If you're already in front of the customer, again, that time is valuable. You want to leave reasons to follow up, but you also want to leave them with something to discuss. If we can provide you with a skid, if we can make it modular. Modular is the key term to just about anything anymore. People love that. They're taking emphasis off site work and people in the field, and they're getting it done in the factory, and we can do that for them and offer that to them. Other things, larger size flanges, more elements, adding thermocouples. It's standard adders in our price guide, which we will obviously provide with the end of the presentation, which is my segue into the end of the presentation. Any questions so far? Everyone stayed with me? Again, silence is a yes. Great.
Yeah, great, Derek.
Okay, good. I'm trying to keep them a little shorter because I've been known to run long lately. So anyway, that's the overview. That's kind of hopefully give you some things to think about, some things to focus on. You'll get an email from me later today. You'll have both presentations. Take them, do whatever you want with them. Take any slides that help you with that. You also get, sizing guides I talked about, those steam calculations. I'll give you those, those I just send to you. Price guide, I'll give you the updated one, the startup, the troubleshooting. You'll have those PDFs to do whatever you need with them. We also did a lot of configurator walkthroughs recently. I'll give you a link to those. And with all these monthly basics, I ask all of you, you'll have a link to a quick exam. It's not difficult. It's only to focus on the key takeaways. So it's as much for you as it is for whoever's tracking this. Take it. You'll get a certificate that you've completed it, or at least that you've bear witness to the materials I covered. So that'll come later today. And with that said, we've got control panels and products next month. Those dates are already set. The invites went out. That would be May 6th, May 13th. If you can attend them both, great. If you can't, remember they're always recorded. They're put on YouTube. They're put on our team site, and they're also emailed out. I want to specifically point out this one because I'm a little excited for it, as James Lewis has agreed to, you don't have to listen to me the entire time, as he's going to walk through, setting up controllers, specifically the 4080s he's going to talk about. It's going to be a really good one to be a part of and walk through and help you understand our control systems a lot better. We'll break down control panels as always, have a couple extras in there. And then, there's the topics going in the future. If there's something specific that you're looking for help on, let me know now, because I can arrange the individual or at least the topic to cover and make sure that it's explained in detail to everyone. And I really appreciate everybody's attendance in the advanced field training. It's just a lot of topics coming in, a lot of different variety of stuff available. We had the Insightly stuff last week, the crash course on that, where Janet, for those who are not utilizing that tool to its fullest potential, you're allowed to ask questions and walk through. Those recordings are available. The value-added selling from Jim, those links are all there. They'll all be part of the email. You can go watch them in your own time. But coming forward, we just had the PPE on Friday, which was kind of just an illustration of the new Wesco safety products that will be available. But for everyone on the call, please be sure to get the pick and ship panels. That will be released shortly. It'll be on the 26th, so a week from Friday. Mark Wheeler will have all the details on that and what's in stock. We're going to have the Direct Connect Evolution update, which will have both the boilers and the heaters, the circulation heaters. A discussion on May 3rd, and we're going to talk BACnet with Jeff Kalis, the individual who provides that, with the more of the commercial side of things on the 10th. Topics and thoughts, send my way. We'll get it on there. And, I guess I'll stick around if anybody has any questions. But that's what I had for today.